Hello everyone and welcome to another episode of Nueri Derres. This is your host Mahmoud Nuer. Today we'll be talking about physics-owned circuits. We're just going to discuss parallel circuits, series circuits. We're going to discuss resistance. We're going to discuss capacitors, etc. As always, don't forget to like, share, and subscribe. Stay tuned, and shall we get started? Alright, let's start. So conductivity can be divided into metallic conductivity and electrolytic conductivity in solutions, and it's measured in Siemens. So basically, that's like you got a piece of metal, you run electricity through it, electrons are going to go through it because it's highly conductive, blah blah blah, or weakly conductive. And then you got a solution which can have a low ion concentration, high ion concentration, and that really helps with how electric charges move through a solution. So you have distilled water with low ion concentration, which can act as a weak conductor or an insulator sometimes. And you have a highly concentration and a highly conductive, a highly ion concentration or highly conductive solution like seawater, for instance, where electrons move there better and conduct there, and it acts as a better conductor. And then current is the flow of charge between 2 points. And the formula for it is I equal charge divided time. And in this equation, Q is the electric charge that flows through a conductor in a given time interval. Next, we have reducing electrical potential, which electrons move from low reduction potentials to high reduction potentials. So the direction and the direction of the flow of electrons is opposite to the direction of flow of the current. Reduction potential, also known as redox potential, and it's the measure of the tendency of the chemical species to gain electrons and undergo reduction. And you can see it commonly in like ETC, electron transport chain, in which from complex 1 to complex 4 goes from low reduction potential to highly reduction potential. Next we have direct current and alternating current. So direct current, it moves in one direction. Alternating current, it moves in both directions. And next we have a potential difference. So potential difference or voltage is the electric potential between 2 points in an electric circuit, and it's produced by galvanic cells like batteries. And V here, voltage, is equal the electric potential or work done in moving a charge through an electric field. And the potential difference is the amount of work required to move a unit of electric charge from one point to another point. The electromotive forces are potential difference with no current produced, such as battery or a generator. Kirchhoff's junction law states that the sum of the current directed into a point is equal to the sum of currents directed away. So current into the junction is equal to current leaving the junction. So for instance, let's say you have a total of 5 amperes into junction, and then you have current B and current C, and current B is 3. So what's current C? Current C is going to be 2. Because 2 plus 3 is equal 5 amperes. It says that the total going in is the total leaving out. Kirchhoff's loop rule is that in a closed circuit loop, the sum of the voltage source is equal to the sum of the voltage potential loop. So V source equal the V potential loop. Next we have resistivity, which is not resistance. Alright, resistivity is an in-string property of resistance, and basically what resistivity measures is how easily current flows in a material. And what an in-string property means is that the property, or it's a characteristic specific to the material and does not depend on the amount of material present. For instance, density, melting point, boiling point, stuff like that, they're all intrinsic properties. And then here in resistivity, it's the resistivity, which is kind of the same symbol as density times length across area. divided area. So cross-sectional area is inversely squared. So if cross-section doubled, for instance, resistance is cut in half. So the more area you have, the less resistance you have. Because an increase in the cross-section area increases the number of conductive pathways. Alright, it means that resistance is going to get weaker, there is more area to cover, and it's harder to cover. So conductors have great resistance at high temperature due to the increased thermal oscillation of atoms in conductive material, which leads to great resistance to the electronic flow. You see that conductors, sure, they also are good at conducting electricity, but they also have a great resistance to high temperature when exposed to it, because they already have thermal oscillation in the conductive material, and you know how electrons, they move quickly, they exert kinetic energy as well, which generates like temperature, and through generating temperature they can also withstand that. Next we have Ohm's law, which Ohm's law is kind of a common law you take in like high school and stuff like that, and it's for a given magnitude of resistance, the voltage drop across a resistor will be proportional to the magnitude of the current, and the way you measure Ohm's law is V equal IR. And then here it says that as resistance increases, current decreases with Ohm's law, and as voltage increases, current also increases. Next we have power. Power is equal current times voltage, or current to the power of 2 times resistance, or voltage to the power of 2 divided resistance. Resistors in series have to travel through all resistors before returning to the cell. Alright, so the voltage has to go through all the resistors before coming back to the cell, and then voltage in the series adds all the resistors, so voltage Vs is equal to V plus 1, V plus 2, V plus 3, and the same with resistance. So resistance and voltage in series, they all add up to the total voltage or total resistance. And resistors connected in parallel, wired from high potential terminal to low potential terminal. If every resistor is in parallel, then voltage drop across each pathway is equal to the voltage of the source. So if resistance is in parallel, it means that, let's say you have a total voltage of like 10, for instance. Alright, so it's for V1 it's going to be 10, V2 is going to be 10, V3 is going to be 10. Resistance in parallel though, you add up all the resistances to equal the total amount of resistance, and the more resistance you add, the total resistance in parallel will decrease. So let's say you have 3 resistors, then you add one more, the total resistance in the whole parallel circuit is going to decrease. So capacitors have the ability to hold charges of a particular voltage, and it's a capacitance ratio of magnitude of charge stored on one plate of the voltage across the capacitor. So capacitors basically, they hold and act as kind of insulators for charges, and then they discharge the charge later. So C, the capacitance is equal to the charge divided by volt, and the unit is farad. So capacitance for parallel. So you place capacitor equal capacitance times the dielectric constant of the material, which is 8.85 times 10 to the power of negative 12, times area area of the overlap of the two plates divided by distance. What is dielectric material? So dielectric material are basically material that are used in, like, electrical engineering and electronics to insulate the conductive material from one another and store electrical energy in capacitors. So common dielectric materials like air, paper, plastic, stuff like that. They basically, what they do is insulate between the plates of the capacitors. And in order to measure the new capacitance, it's the dielectric constant times capacitance. Alright, so let's say you have a new dielectric constant introduced, so you're gonna have to measure the new capacitance by multiplying the old capacitance by the dielectric constant, the new one. And then you have capacitors in series. So the total capacitance decrease as more capacitors are added because capacitors share voltage drop in a loop. It's the same thing as resistors and parallel. Resistance decreases the more you add um, resistors. So, but resistance, this happens in parallel. Here it happens in series. So kind of capacitors are the opposite of resistors. Capacitors in a parallel produce resultant capacitance that is equal to the sum of individual capacitance. So the capacitance increase as more capacitors added. So the total CP, the capacitance in parallel, is equal to C plus 1 plus 2 plus 3. Next we have ammeter, voltmeter, and ohmmeter. So ammeter basically measures how electricity is flowing through a wire. And then it's like connected in series with the circuit, meaning all the current flowing through the circuit flows through the ammeter, and it has low resistance. Kind of doesn't have any effect on the circuit. The voltmeter measures how strong the electricity is in the wire, and it has really high resistance, and it draws some current, very little current from the circuit. And then the ohm meter basically has a battery and determines the resistance of the component or the circuit. And that's it. Thank you so much for listening and tuning in, and please let me know if you have any questions, and have a blessed day.